Welcome back. We're going to take a look at how we can take a common table expression, make it even potentially more powerful by using a recursive CTE. So recursive CTE, or recursive common table expression, are really helpful when I explore a hierarchical relationship of data. And so as with recursion in Java, Swift, C++, you need to make sure you have a base case to handle that thing, what to do when you want to stop for that. And when we're looking at the recursive common table expression, each iteration of that recursive operation operates only on the previously recorded data. So you want to make sure you define that really, really well. So recursive constraints, there are no aggregate functions in the recursive part of the CTE. That makes pretty much good sense because you're generating those values as you go through it. So you can't really have an aggregate function on there, which also means, of course, no group by function call, which also means no group by clause as well. Oh, no big deal. There's no use of order by inside recursive CTE. I know that's really weird. That makes sense. Okay, never mind. There's no distinct, and you must have a logic in the recursive call. These are some just pretty much standard rules for writing a good query, but you have to actually explicitly put that in when you're working with recursive common table expressions, so keep that in mind. I'm working with Oracle right here, so the recursive CTE syntax is specific for Oracle CTE specifically. Other databases might have other rules. Take a look at the vendor information to see how that works. The fields of a query need to be specified in an alias list at the top of the actual CTE. The anchor query is always specified first inside that, and then use the set operation union all so you can combine those results. This is pretty critical so you can actually combine those values together. And then we have a recursive query with the logic to close it off afterwards. So that's just the basic structure we're working with. So here we can see that example right here. So recursive CTE, I'm not doing the actual details of the query. I'm just looking at how the actual structure happens. So with demo, and then I have my field alias list num as, and then I have my anchor query select from union all, which is my base case right there where I'm starting with the base that I'm working with. And then I have my select from and my where clause, which has the limits to stop that recursion right there, and then select everything from that query. So I've got to run that right there. So let's take a little bit deeper look on that. So the anchor query right here, I'm going to select one from dual again because I'm working with Oracle. If I want to do an empty query, I have to use the dual table for that. And then I have my union all right there for that anchor query and the associated call to union all. And then we have our recursive query. So I'm going to just collapse that down and I'm going to select whatever I'm working with from demo where the num, that reference back to that recursive table, is less than 10. So I'm working with the table I've defined up above in that CTE. And then my reference to my field in there, num in this case for my logical end, I'm going to go until it's less than 10. Let's take a look at the recursive common table expression with a hierarchical query right here. And so I have with hierarchy demo, I've got my subject code, my course number, my prerequisite and course ID. I have my alias list specified right here. I have my anchor query right here where I have the subject code, the course number, and the prerequisite, and the course ID from courses, as long as the course prerequisite is null. So I've got that value right there. And then for the hierarchical query right here, again, I have that same stuff right there. I'm going to select the subject code, the course number, the prereq, and the course ID from courses. And I'm joining hierarchy demo. So I'm going to join my information of that previous common table expression up above on the demo.course ID matches the core.prerequisite. So I've got the recursive query right there, and I've got that reference so that they're going to have a match right there, which will cause me also to limit my results so they only match with that. So my recursion will stop based on that on clause. The on clause right there will make it so I have that hierarchy happening so that my recursive results actually stop because they only match for the exact value with that. And so that's the way we can actually do a recursive common table expression for hierarchical queries as well as for just general recursive common table expressions. I hope this is a helpful review of how you can actually work with a recursive common table expression. Cheers, see you next time, have a good day, bye-bye.